Hello, today let's take a look at section 1.6. We're going to talk about a library of parent functions. What does that mean? That means that when you see an equation, you should visualize what the graph will look like. So we have linear equations, which we've done in Algebra 1 and Algebra 2. We have quadratic equations. The shape of that we call a parabola. We have a cubic, y is equal to x cubed. Notice that one side of the graph points in one direction and the other side of the graph points in another direction. Also know, now that we've talked about even and odd, this is symmetric with the origin. We have the square root function, which starts at 0 and arches out like half of a parabola. We have what's called a reciprocal function. The parent function is the simplest plain vanilla form of the equation. F of x equals 1 over x. I do want you to go through and read all these notes. It talks about the domain. Why does the domain look like this? Can x be 0 if it's in the denominator? No, it cannot. So it can be any number up to 0, notice not including 0, union with any number from 0 to positive infinity. The infinities, remember, in interval notation are always open. The range of the function goes from negative infinity to positive infinity, but notice the value of this function is never equal to 0. This can never equal 0. I'll let you ponder that, why that is true. So go through all the details. Piecewise and step functions, we're not going to worry too much about those. It's worth taking a look at it. And then here we go with graphing a piecewise function. I will let you go through example 3. In my experience, this has been where students have had the most difficulty graphing an equation. I'm going to show you one extra example. And then here is kind of a summary of all the parent functions that you should be able to be familiar with. So the one example that I'm going to show you is number 36 on page 65. It is. This is an example of how to graph a piecewise function. So f of x is equal to 4 plus x for x less than or equal to 2, or it's equal to x squared plus 2 for x greater than 2. So I've written that down over here. I'm going to sketch a graph. So basically, we're going to have two different functions here, and the break is when x is equal to 2. So we're going to kind of have a line. You can draw a little dash line there, right? Okay, how do we do this? Let's put in the value of 2 right here. So if x is equal to 2, 4 plus 2 would be 6. When x equals 2, y is 6. Let me go 1, 2, 3, 4, 5, 6. And I'm going to put a dot here. Now I'm going to ask you, is that going to be a solid dot or an open dot? We have x is less than or equal to. What do you guess that would be? I hope you said solid dot, right? And now for all the x's less than or equal to 2. So choose any number you like that's less than or equal to 2. How about 0? So if x is 0, 4 plus 0 is 4. So if x is 0, y is 4. 2 points determine a line. Now I'm not going to go through it like this because this function is only defined for values of x that are less than or equal to 2. So it goes like that. All right, now my second equation, x squared plus 2, I'm going to use 2 again here, and I'm going to evaluate, but when I put it on my graph, I'm going to use an open circle. All right, so if x is 2, 2 squared would be 4, plus 2 is 6. Oh, lo and behold, it's the same. So we have an open circle here. Doesn't matter that we can't really see it. Now choose any number that's greater than 2. How about 3? So if x is 3, 3 squared is 9, plus 2 would be 11. So if x is 3, y would be 11. This is 6, 7, 8, 9, 10, 11. This would be better on your graph paper. Now, am I going to make a straight line? What do I know about this equation? This equation is a parabola. That is, we're going to look soon at transformations. It's been shifted up, but it's a parabola. So it's going to be curving up. If you're not sure about the curve, you could do another point at 4. 4 squared is 16 plus 2 is 18. That's just kind of getting off my graph a bit, right? So anyways, so here is this graph. So we have a straight line because this is linear, and then we have a parabola for this point. You might want to watch this description one more time because it is a bit confusing. So do make sure that you go back and read more closely through the notes, and that's all for 1.6.